Hello everyone, welcome to CAIE Science, and today we will be solving May June 2022 paper 2-1 of A levels 9701. So let's begin. Question number 1, part A. Magnesium has a melting point of 650 and a high electrical conductivity. Explain these properties of magnesium by referring to its structure and bonding. So it has a high melting point, so it must be a giant structure, and secondly, it conducts electricity. So it must have metallic bonding. Okay, so it has giant metallic structure and delocalized delocalized electrons can move through the structure. Okay, through the structure. Part B. When magnesium is heated in air, magnesium oxide is the major product. Smaller amount of magnesium nitride are also formed. Okay, calculate the oxidation number of magnesium and for nitrogen species in magnesium nitride. Okay, so oxidation number of magnesium, if you see here, if magnesium has oxidation number of 2 plus and nitrogen has 3 minus, then the formula is going to be Mg3N2. So magnesium has a oxidation number of 2 plus and nitrogen has a oxidation number of 3 minus. Okay, identify the type of reaction which takes place between magnesium and nitrogen. Explain your answer. Okay, so this is a redox reaction because magnesium is oxidized and nitrogen is reduced. Okay, part 3. Define enthalpy change of formation. So it is the enthalpy change when 1 mole of a compound formed from its elements in standard states. Okay, this is the enthalpy change of formation. Okay, part 4. When 3.645 gram of magnesium burns in excess of nitrogen to form magnesium nitride, 23.05 kilojoule of energy is released. Okay, calculate the enthalpy change of formation of magnesium nitride. So you are working. Okay, so here if I write the equation, magnesium reacts with nitrogen to form magnesium nitride. Okay, so this is the equation, and here we are given mass of magnesium and nitrogen is in excess. So firstly we will calculate moles of magnesium. So 3.645 divided by mass of magnesium, you can see from predictable it's 24.3, so it's going to be 0.15 moles. Okay, so and from ratio you can see that moles of magnesium nitride formed. Magnesium nitride formed is equals to 0.15 divided by 3, going to be 0.05. Okay, and now you are giving the energy change, energy which is released. And if you want to calculate enthalpy change of formation, so this is the formula of enthalpy change of formation of magnesium nitride. So you have to divide energy released with moles formed. Okay, so from here you will get minus 461 kilojoules per mole. Why I'm adding minus here? Because this is the exothermic reaction, because this is the bond formation, and bond formation is an exothermic reaction. Okay, bond formation is an exothermic reaction. So this is minus 461 kilojoules per mole. Okay, moving towards question number 2. Radium is an element found in group 2 of the periodic table. It is a crystalline solid at room temperature and conducts electricity. Okay. Radium chloride has a high melting point and is soluble in water. Predict the latest structure of radium chloride based on these properties. So it has a very high melting point, so it must be a giant structure and soluble in water, which means it has ionic bonding, because covalent compounds are usually insoluble in water. So this is giant ionic. Okay, giant ionic structure. Okay, draw a dot and cross diagram to show the arrangement of outer electrons in radium chloride. So in radium, it is a group 2 element, so it must have 2 electrons in outer shell. And when it uh, it forms it reacts with chlorine, so it forms radium chloride, and in this reaction it loses 2 of its electrons from outer shells, so its outer shell is empty now. Okay, it will lose both of his electrons to each chlorine, one electron to each chlorine. So it has now no electrons in outer shell. Its outer shell is now empty. And chlorine, on the other hand, has 7 electrons in its outer shell, like this, and it has gained 1 electron from radium. So it has a charge of 1 minus. Okay, and same like the other chlorine, it also has 7 electrons initially, and it has gained 1 electron from radium, which you have to show. Okay, like this. Okay, question number C, part C. Solid radium and calcium show similar reactions with water, but reactions occur at different rates. Okay, separate samples, each containing a single piece of solid radium or calcium, are added to equal volumes of cold water. Each sample contains equal number of moles of solid and water is in excess. Construct an equation for the reaction of radium with water. So when radium or other group 2 metals react with water, they form hydroxides. So this will form radium hydroxide plus hydrogen gas. Okay, balance it. Identify which element, radium or calcium, react with water at a faster rate. Suggest how the observation of each reaction would be different. So radium would react more vigorously because the down the group the shells increases, so there is more shielding factor, so it lowers the activation energy. So that's why radium will react more rigorously. So radium and because more, and what will you observe here which will show that reaction in magnesium is faster, there will be more fizzing and solid disappear more quickly, and solid disappears appears more quickly. Okay, in radium the solid will disappear quickly than in calcium. Okay, suggest why these reactions occur at different rate, because radium has lower activation energy, because there is a shielding factor, greater shielding factor in radium, because if you see in the periodic table, this is uh, radium, this is radium, and this is calcium. Okay, so radium has more electron shells, so its distance of outer shell electrons from uh, the nucleus is greater. Okay, so that's why the activation energy is lower, or ionization energy is lowered. Okay, so what will you write? Ionization, you can write in ionization energy terms as well. Ionization energies are different as because because different distance from nuclear, or you can write is as like this. Let's make it a little more different. Ionization energies are different, and a decrease in nuclear attraction. Nuclear attraction due to due to increased due to increase in distance of outer electrons from nucleus. Okay, so the distance of outer electrons from nucleus increases, so the attraction of nucleus to the outer electron decreases. So that's why it is easy to lose electrons, and ionization energy is lowered in radium. Okay, part 4. One of the solutions is cloudy when the reaction has finished. At the end of each reaction, universal indicator is added to each reaction. Suggest pH values of the solutions made in reactions. Explain your answer. So down the group, the solubility of hydroxide increases. Okay, hydroxide, the group to hydroxide solubility increases down the group. So calcium is less soluble than radium. Okay, and calcium will form these cloudy ppt. Okay, the calcium hydroxide is less soluble, and down the group hydroxide solubility increases, so radium hydroxide is very soluble. Okay, so the pH value of radium hydroxide will be greater than calcium hydroxide, because not all of the calcium hydroxide is dissolved, so less concentration of OH in solution. Okay, so pH of radium is, I would say, like 14, and pH of calcium is like uh, 12, because because solubility of group 2 hydroxides decreases down the increases down the group, and more so more concentration of OH ions OH ions in solution in of radium. Okay, radium hydroxide. OH ion will have greater concentration in solution of radium hydroxide. Okay. Part D. A sample of aqueous calcium halide contains either chlorine, chloride, bromide, or iodide. Okay, ions. Complete table 2.1 to describe a two-step process that could be used to identify halide ion present. So this two-step process is, in first step we will use silver nitrate plus nitric acid. This is the silver nitrate in nitric acid is used to find the which halide is formed. This is the test for halide ions. Okay, with chlorine it forms white ppt of silver chloride, white ppt, and with bromine it forms cream ppt, bromide ions, cream ppt, and with iodide ions it forms yellow ppt. Okay, and in second step we will use aqueous ammonia, and in aqueous ammonia chlorine is soluble. Chloride ions are soluble because they form a complex which is soluble. Okay, so ppt dissolves. Okay, ppt dissolves, and with bromide ions uh, ppt will partially dissolve. Okay, ppt partly dissolved, partly soluble. Okay, and in iodide, when you add it, when you add silver iodide in ammonia, it is insoluble in ammonia, aqueous ammonia. ppt is insoluble. Okay, so from here you will find which halide is present. Okay, question number 3. 0.015 mole of hydrogen iodide is added to closed vessel and left to reach dynamic equilibrium. The total pressure of the vessel is 100 kilopascal. Okay, the equation 1 is shown. Explain what is meant by dynamic equilibrium. What is meant by dynamic equilibrium? State at which the rate of forward reaction forward reaction is equals to backward reaction, and concentrations concentrations of reactants and products are constant. Okay. Part 2. Describe one difference in the initial appearance of the reaction mixture compared to the mixture at equilibrium. So initially, when you add hydrogen iodide, so the initially there is no iodine formed. So hydrogen iodide is a colorless gas. So initially, the appearance of the mixture will be colorless, and when iodine will form, it has purple vapors. So it will turn into purple. Okay. So what will you like? Colorless gas becomes purple. Okay, it has purple vapors, purple gas. Write an expression for Kp. This is the Kp is partial pressure. Okay, for the reaction describe in equation 1. So equation 1. So Kp is concentration of products divided by concentration of reactant. Yes, so here partial pressure of hydrogen multiplied by partial pressure of iodine, partial pressure of iodine divided by partial pressure of hydrogen halide, and it will have a square because there are 2 moles of hydrogen iodide, so the moles will be in square or in power in the Kp equation. Okay, so this is the equation for the reaction in equation 1. Okay. Part 4. At equilibrium, the partial pressure of hydrogen iodide is 36.4 kilopascal. Okay, calculate amount of hydrogen iodide gas present in the mixture equilibrium. Show your working. So the formula for partial pressure, calculation of partial pressure is partial pressure is equals to moles of gas divided by total moles multiplied by total pressure. Okay, so this is the formula, and here you are given partial pressure which is 86.8, and you have to find the amount, so it is the mole. Okay, so moles of gas, I am writing this as let's suppose x, and total moles you are given, and but you have to read through carefully. So this is the total moles. Okay, because initially this is the moles of hydrogen iodide initially which you added into the closed vessel, and there is no formation of initially there is no hydrogen or iodide present in the reaction mixture. So this is the total moles. Okay, at equilibrium 0.025, and you are giving total pressure which is 100 pascal. This is the total pressure. Okay, and from here you will calculate the value of x. Okay, so x is going to be 0.0216. Okay, so this is the moles of hydrogen iodide present in equilibrium mixture. Okay, 0.0216. Okay, moving towards next question. Part B. Use equation 1 and bond energy values in table 3.1 to calculate enthalpy change for the thermal decomposition of 1 mole of hydrogen iodide. Okay, so equation 1 I'm writing this here. So this is the equation 1. Now you are giving bond energies. So from here we will calculate the enthalpy change. Enthalpy change is equals to in bond energies we subtract the reactants bond energies from products. So reactant bond energy is hydrogen iodide, and there are 2 moles. So 2 minus 1 mole of hydrogen. So bond energy of hydrogen is 436 plus iodine has 151, and here you will get uh, 11. But this is not the answer, because this is for the 2 moles of hydrogen iodide, and in question you are said that find the enthalpy change for the thermal decomposition of 1 mole of hydrogen iodide. So for 1 mole you have to divide it by 2, which is 5.5. Okay, so this is the enthalpy change for the 1 mole of hydrogen iodide thermal decomposition of 1 mole of hydrogen iodide. Okay, part C, describe the effect of increasing pressure on the value of Kp for the thermal decomposition. So there is no effect, because there are same number of moles of gas on the both sides. You can see here that there are 2 moles of gas here, and 1 plus 1, so 2 moles of gas on both sides. So either you increase the pressure or decrease the pressure, there is no change in equilibrium position, so there is no effect on the Kp value. Okay, so no change. Part D, hydrogen chloride is prepared by adding sodium chloride to concentrated H2SO4, and hydrogen iodide is not prepared by adding sodium iodide to concentrated H2SO4, because the hydrogen iodide produced also reacts with concentrated sulfuric acid. Okay, identify the type of reaction that occurs when sodium iodide reacts with uh, concentrated H2SO4 to form hydrogen iodide. Okay, so this is the acid base reaction. Okay, this reaction is acid base reaction. Write an equation for the reaction of hydrogen iodide and concentrated H2SO4. So hydrogen iodide reacts with concentrated H2SO4, and this reaction has 3 equations. So I am writing the possible equations. H2SO4, so it can form H2O plus sulfur plus iodine. Okay, and this is iodine is in solid form. Okay, this iodine is in solid form, and you can balance this equation like this, to like this. Okay, so this is the first equation. Secondly, can react with concentrated sulfuric acid to form water plus sulfur dioxide plus iodine. This is in vapor form. Okay, so like this, and lastly H2SO4, this forms water plus H2S, hydrogen sulfide plus iodine. This is also in solid form. Okay, so in from these equations you can write any of the equation. Okay, so I'm, for suppose, let's writing this equation. Okay, now you can write this equation as well, and because in marking sim it has given this equation to you. Okay, so let's write this equation plus H2SO4. So this forms um, iodine, it is in solid form, plus hydrogen sulfide plus water. Okay, and balance it. Moving towards next question. Question number 4. Bromine reacts with butane in the presence of UV light to form bromobutane. Two structural isomers with the molecular formula H4 and H4 C4H9 and Br are produced during this reaction. Draw the two structure isomers. State the systematic name of each isomer. So it can form like simply like a straight chain, which is CH2, CH2, CH3, CH2, CH2, and CH2Br. This is the first isomer, structural isomer. And secondly, it can also be like this: CH3, CH2, CHBr, and CH3. So this is the name of this is 1-bromobutane and 1-bromobutane, and this is 2-bromobutane. Okay, just the position of the functional group is changed. Okay, so identify the type of structural isomer shown. So this is the positional isomer. Positional. Okay, halothane is an anesthetic. Okay, identify the chiral center in halothane and mark it with a steric. Okay, so chiral center is the carbon atom which is attached to 4 different groups. So if you see here, this carbon, this is attached to 4 different groups. So we will put an steric over here. Okay, construct an equation to show the homolytic fission of halothane. Okay, so there, this is the homolytic fission. And oh sorry, and here it says when halothane reacts in UV light, homolytic fission occurs and CBr bond is broken. Okay, so CBr bond is broken. Okay, so here we will write in the equation CF3 PBr PLH. This undergoes homolytic fission and Br bond CBr bond is broken. Okay, so CHCl dot plus Br. This is the homolytic fission. Okay, and no charge on any species. Okay, complete figure 4.2 to show the arrangement of electrons in bromine atom using the electrons in boxes notations. So if you see from periodic table, what is the atomic number of bromine? So it's 35. So bromine has 35 atoms. Okay, and let's see how many electrons argon have. Argon have 18 electrons. Okay, 18 electrons. Okay, so now how much we are left with? We are left with 17 electrons. So we have to arrange 17 electrons now, because argon here given, it means 18 electrons are drawn. Okay, so now we have to just put 17 electrons. So here this 4s is the lowest has a lower energy than 3d. So firstly electrons can go here. Okay, will go here like this. Then in 3d it will be arranged like this. One is firstly all the orbitals will be unpaired, then they will be paired one by one. So how many electrons we have? drawn 2, 4, 6, 8, 9, 8, 10, and 12. Okay, so 12 electrons are drawn and 5 more. Okay, so then in 4p, like this, and then like this. Okay, so this is the electronic configuration of bromine atom. Okay, part C, X is an addition polymer. Okay, draw the monomer of X. So if you draw this in displayed formula, this is CH2 and CH and CH2Cl. Okay, so this is the monomer, polymer, sorry. So what will be the monomer? Okay, so the monomer will be C a double bond. Here you will add double bond. Okay, in the monomer, C double bond, CH CH2Cl. Okay, so this is the monomer, but you have to draw the monomer in skeletal formula, because in question you are given a skeletal formula. Okay, so try to draw structures in the formula which is given in question. Okay, so this is the skeletal formula. Okay, 1 2 3. Suggests one reason why disposal of items made from X is difficult, because double bond is when polymers made from double bonds are difficult to hydrolyze, and they are non-biodegradable. Non-biodegradable. Okay. Moving towards next question. Question number 5. Figure 5.1 shows three reactions of 2-bromopropane. Bromopropane. Okay. Complete table 5.1 for each reaction by studying reagent and conditions used. Identify the type of reaction that occurs. So in first reaction, Br is substituted with OH, hydroxide. So this is the nucleophilic substitution reaction, because both bromidine and OH minus ion are nucleophiles. Okay, so because they both have lone pairs of electrons. So this is the substitution or nucleophilic substitution reaction. You can write it as nucleophilic substitution reaction. And what is going to be the reagent? The reagent is sodium hydroxide, but in aqueous, because if you add this sodium hydroxide in ethanol, it will form alkene like this in reaction 3. Okay, so the reagents are NaOH, aqueous, and the type of reaction is nucleophilic substitution, or you can simply write substitution reaction. Okay, and in reaction 2, the reagent is ammonia, because this form amines, and this ammonia displaces, this ammonia is also a nucleophile. Okay, acting because nitrogen has lone pair, so this is also nucleophile, and it will displace the bromidines. Okay, and will form amine. Okay, so and the conditions are this reaction will happen in ethanol, in the presence of ethanol, ammonia in ethanol, and heat under pressure. Heat under pressure. And this is also a substitution or nucleophilic substitution reaction. Okay, and in part 3, the reagents are sodium NaOH in ethanol, and heat under reflux. Heat under reflux. and this is elimination reaction because water is eliminated. Oh, sorry, HBr is eliminated. Elimination reaction. Okay, HBr is eliminated, so double bond is formed. Okay, part B. A sample of 2-iodopropane reacts under same condition as reaction 1 to produce CH3 CH CHOH CH3. This is propane 2-ol. Okay, in okay, this is 2-bromopropane and this is 2-iodopropane. Okay, explain why 2-iodopropane reacts at faster rate than 2-bromopropane, because the bond energy of carbon iodine bond is weaker than CBr bond. Okay, that's why uh, this reaction happens faster, because this bond breaks radially than this bond. Okay, so what will you write? Pi bond is weaker because it has lower activation energy. Okay, so this reaction has lower activation energy, so this reaction happens at faster rate. Okay, part C. Figure 5.2 shows how butanol can be made from 1-bromopropane in 3 steps. Okay, in step 1, bromopropane reacts with cyanoines to form butanitrile. Complete figure 5.3 to show the mechanism for the step 1. Include charges, dipoles, lone pairs of electrons, and curly arrows. Okay, so in this reaction, the mechanism, the Br has a partial negative charge and carbon has partial positive charge, because electrons are more attracted to bromidine, because this is more electronegative, and the lone pair on this carbon cyano will attack this partial positive charge of carbon, partial positively carbon. Okay, so this is the mechanism for the reaction, and here you will just have to add lone pairs to bromidine. Okay, so this is the mechanism. Okay, and step 2, butanitrile is heated with HCl. Okay, a hydrolysis reaction occurs. Construct an equation for the reaction. Okay, so for this hydrolysis reaction, um, okay, it's butanitrile. Okay, so CH3 CH2 CN plus, it reacts with HCl and water as well, to form, and when this is hydrolyzed, it forms carboxylic acid. Okay, so CH3 CH2 and COOH plus, it forms ammonium ion, because it is an acidic conditions, so this will form ammonium ions, and Cl is also present, so ammonium chloride. Okay, and balance the equation like this. So this is the balanced equation. Okay, step 3 is a reduction reaction. Construct an equation for the reduction reaction. In step 3, use H to represent one atom of hydrogen from reducing agent. Okay, so in step 3, carboxylic acid is reduced to alcohol. Okay, so it's butanoic acid, so CH3 CH2 and COOH plus H, so it forms alcohol and water, and this alcohol is butanol, CaOH plus water. Okay, and balance the equation and identify the suitable reducing agent. So the reducing agent which can reduce carboxylic acid is uh, lithium tetrahydroxyaluminate, which is LiAlH4. Okay, because you cannot reduce carboxylic acid with NaBH4 or LiBH4 because these are uh, not enough strong reducing agents to reduce carboxylic acid. So it's LiAlH4. Okay. Question number 6. Z is a molecule which contains elements carbon, hydrogen, and oxygen only. Z contains only alkene and carboxylic functional groups. Okay. Complete table 6.1 by describing the observations that occur when two different reagents are added to two separate samples of Z. So when bromine, aqueous bromine is added and it contains an alkene, so means double bond, so the bromine water will decolorize. Okay, orange color disappears. Yeah, or you can write as orange to colorless. And with sodium carbonate, because it contains carboxylic functional groups, so acids react with carbonates to form carbon dioxide, so you will observe fizzing or bubbles. Okay, so these are the observations. Okay, moving towards next part B. Table 6.2 shows the percentage by mass of each element present in Z. Okay, use data in table 6.2 demonstrate that the empirical formula of Z is CHO. Okay, so for carbon, hydrogen, and oxygen, 41, 41.38 percentage, then 3.45, then 55.1. Okay, and oxygen has a MR of AR of 16. You can see this from periodic table, their ARs. Okay, and carbon has a AR of 12. So from here you will get 3.45, 3.45, and 3.45. So this shows that it has a empirical formula of CHO. Okay, moving towards next part C. Figure 6.1 shows the mass spectrum of Z. Deduce the molecular formula of Z. Explain your answer by referring to the molecular ion peak and in figure 6.1 and the empirical formula. So now you have to calculate molecular formula, and molecular formula is a formula of molecular formula is equals to mr divided by empirical mass. Empirical mass. So mr you will find from this graph, and the molecular ion peak is this, the last peak, and it has a mass to charge ratio of 1:116, and this is the mr of the mr of Z. Okay, 1:116. Mr molecular ion peak gives you the mr. Okay, you have to remember this. Molecular ion peak gives you the mr, and empirical mass you have calculated empirical formula, which is CHO. So you can uh, calculate that 12 plus 1 plus 16, and from here 1:116 divided by 29, so it's going to be 4. Now you have to just multiply 4 with empirical formula, so C4H4O4. This is your molecular formula. Okay. Use figure 6.1 to suggest the formula for the fragments with the molecular mole to charge peaks at 45 and peak at 71. Okay. So now uh, it told you earlier that it contains an alkene and carboxylic function, and it has 4 carbons like we have calculated in this uh, molecular formula. So if I draw like this, it has an alkene, like for suppose an alkene and an carboxylic group. Okay, like this. So if I break the bond from here, if so, what's going to be COH group will break down, and this group will break down. Okay, so what is the mass of this COOH? So 12 plus 16 plus 16 is 32 plus 1. So it is 45. So now you know that the peak at 45 is due to the breakdown of COOH group or carboxylic group. Okay, so the peak at 45 is due to COOH plus group. Okay, now if you subtract this molecular ion peak 116 minus 71. Okay, sorry that interruption. So if you divide this 116 from 71, because you have to now find the peak at 71, so if you subtract this, so you will get 45. So you know that the 45 is removed from the compound. Okay, and this 45 peak is due to the COOH group elimination, a breakdown of this group. Okay, so now what will be the if you subtract this C4H4O4 and subtract this from COOH, so what you are left with? You are left with CH3 and C3H3 and O2, and this is going to be plus. So this at 71, you the peak at 71 is due to C3H3O2 plus. Okay, now part 3, suggest the structure of Z using the relevant information from table 6.1 B and T. Okay, so from here you are sure that you have a carboxylic acid here, and you have an alkene. So let's suppose I draw the alkene group here. So if this is we will find the structure by head and trial method. So let's make this as an alkene like this. So if you calculate this mass of this molecule, so what's this going to be? C4 and H, how many H? 1 2 3 4 5 6 6H. So it's not going to be the correct structure because we have 4 H hydrogen atoms. Okay, so if I draw the uh, let's make it here. If I draw the alkene here and on the second carbon, and this is like this, so if you attach now an other carboxylic acid group, because you have 4 OH O oxygen groups, so now you see C4H4OH, and I told you that it contains only alkene and carboxylic group, so it means you can't have another group in this compound. So this is the structure, and but you have to draw this structure. You can draw in a skeletal formula as well. So but this is the structure. Okay, so I'm drawing this structure like this. So this is the structure. Okay, so that's all for the day. Thank you for watching, and if you haven't subscribed my YouTube channel, do subscribe. Thank you.